Hey guys, Anisha's PyMasters Scholars here. So today we will be learning prefix sums. Prefix sums are basically a technique in Python that is used to calculate cumulative sums. And then once we learn prefix sums, we can write a function that returns the sum of any sublist between two indices in a list. And that's one of the main purposes of prefix sums, is to do that, to return the sum of a sublist efficiently in just a single statement. So basically how a prefix sum works is a prefix sum is basically we're creating a new list or a new array in other programming languages, but we're creating a new list that stores the cumulative sums of the values of the original list. So for example, at index 0, the cumulative sum of 3, so let's say we have this list L and then we create a new list called P. So at the index 0 of P, what needs to be stored is the cumulative sum of all values until index 0. So at index 0 of list P, I need to store the cumulative sum of all values in the original list L until index 0, and that would obviously only just be 3. So the first element in the prefix sum list is just equal to the first element in the original list, because all the cumulative sum of values until index 0 is just equal to the first value, or the value at index 0 of the original list. So now that we have gotten the first element, now we need to get the second element of the prefix sum, and the second element is just going to be equal to the cumulative sum of all the values until index 1, which in this case would just be 3 plus 5 in the original list, which is 8. And then now we need to get the third element, and the third element that will just be equal to the cumulative sum until index 2 of the original list. That will be 3 plus 5, which is 8, plus 7 is 15. And so that is how we get the cumulative sum list, or the prefix sum list. So you see here at index 0, we just have 3, because that's the cumulative sum at index 0. At index 1, we have 3 plus 5. That's the cumulative sum at index 1. At index 2, we get 3 plus 5 plus 7, which is 15. That's the cumulative sum of index 2. So the way this looks like in code is first off, we already set the first element of the prefix sum to the first element of the original list, because we know that those values are equal. And then when we get to the next element now that we have to add to the prefix sum, how we figured that out is, now in our loop, our pointer is pointing at 5. Right? We already skipped this element. The pointer is pointing at the second element now. And then we need to add this second element to the continuous sum, or the prefix sum, of the values before this element. And we know that the continuous sum of the values before this element is just the value of the prefix list at 1 less than that index. So if we're trying to figure out the continuous sum, or the cumulative sum at index 1, we have to add whatever the value is at index 1 to the cumulative sum of all values before index 1, which would just be 3. So we're adding 5 to whatever's in the prefix sum list, so 5 plus 3 is 8. And then now we shift that pointer over to 7. And then now we add 7, which is at index 2. And then to the cumulative sum of all values before index 2, which is the cumulative sum until index 1. So that would be P, the value of the prefix at index 2 minus 1. So the value at the prefix at index 1 is 8. 8 plus 7 is 15. So we're always looking for we're always looking for the value of the prefix sum at the index minus 1, so at the index right before, because that will give us the cumulative sum of the values before that index, or before that value, and then we add that value to update that cumulative sum and fill that spot in to the corresponding index. So if that's confusing, we can do another example. So let's say we had a list, maybe a little bit larger list. We have 1, 3, 7, -2, 9, that over. And then let's say now you have to fill in a prefix sum. We create a new list. And then so we can fill in the indices 1, 2, 3, 4. So the first value of the prefix sum is just the cumulative sum at index 0, which is just equal to the value at index 0 of the original list, which is just 1. And then now the second index should be equal to the cumulative sum for index 0 and index 1, so the cumulative sum for all values before and including index 1, which is 1 plus 3, that's 4. And we get that by adding 3 to the original cumulative sum, which is 1, so 3 plus 1 is 4. And then now we want to add 7 to the cumulative sum, so the cumulative sum until 2 is 4, and then now that the value at index 2 is 7, we do 7 plus 4, that would be 11, so 11 is the cumulative sum at index 2. The cumulative sum before index 3 is 11, and then the value at index 3 is negative 2, so 11 plus negative 2, 9. And then we add 9 to our cumulative sum before 4, which is 9, so 9 plus 9 is 18. Oops. And then so if you look at the list, so you'll see 1, and then 1 plus 3 is 4, 1 plus 3 plus 7 is 11, 1 plus 3 plus 7 plus negative 2 is 9, and then add everything up and that'll give you 18. So we keep updating that continuous sum as we go to the right. So the key idea is that whenever we're updating a value in our prefix sum, we're adding the current, what our current pointer is in our for loop, what value is currently being pointed to, or the value that we're currently on in the original list, plus the value at in the index minus 1, or the value 1 before the index in the prefix sum, because that will give us the continuous sum or the cumulative sum of all the values before that index. So it will make more sense when we do code. So for example, so let's say that we had a list, and we'll call this list li. That was equal to just 3, 5, 7. So now, if we have to write an algorithm to compute the prefix sums, so you want to create a new list, so we'll call it prefix. And that's equal to, and we could set it as an empty list, or since we already know that the first element of the prefix sum is going to be equal to the first element of the original list, as already demonstrated, we could just fill in the first element to li at index 0. And then we want to loop through, or we want to iterate through this li list, so we're going to go through for I in range, and then we're going to start at index 1. So we've already filled in index 0, we can skip that. We're going to start at index 1, or the value at index 1, and we're going to go until we get out of bounds, so the length of li. And then we're going to add to the prefix, so prefix.append, and then what we're going to add is we're going to add li at I, which is the value at that index in the original list, plus, and then remember we're trying to get the cumulative sum, so we want to get the continuous sum of all values before that index, and so we can get that using our prefix at I minus 1. Because prefix at I minus 1 will get us all the cumulative sum of all the values before that index, and then we add that to the value that we're currently on in the list, and then we can update that cumulative sum to fill in that new index. So we're just keep adding on to that current cumulative sum to fill in the new index. And then if we were to print prefix, we can see if it works. And then you can see here we have 3, so 3, and then 3 plus 5, which is 8, that's our next index, and then 3 plus 5 plus 7 is 15, that's our last index. So you can see it works here. So now the next thing, so cumulative sum right now, might seem pretty pointless. It's simple. All we're doing is creating cumulative sums. The entire point of this is that we are able to compute the sum of sublists. So if we're given two indices, we're given a left bound and a right bound, a left index and a right index, we can compute the sum of that sublist now in just one statement, or in just one command. So for example, if we look at this example right here, let's say that I wanted the sum of the sublist between 0 and 2. I wanted to compute the sum. I needed to write a function that computes the sum of the sublist between any two indices, and let's say I passed in 0 as my left index, 2 as my right index. So the way that I can do this is, so let me remove this. So I want to get this the sum of this sublist right here, the 137. And so the way I can do this with prefix sums now is prefix sums give me the cumulative sum. So you think about it, it gives you the continuous sum. If you were to subtract, so if I wanted to see how much sum was gained between that interval, or on the interval from index 0 to index 2, all I have to do is p at index 2, so the prefix sum at index 2 minus the prefix sum at index 0. So the prefix sum at index 2 gives us the cumulative sum of all values until and including index 2. The p at 0 just gives us the first element, or the cumulative sum of all values until index 0, including index 0. So that gives us how much sum was gained mathematically. That gives us how much sum was gained from index 0 to index 2, because it gives us the cumulative sum at 2, cumulative sum at 0, so we can see how much total sum was gained or how much sum was lost. And so if we do that, so p at 2 is 11, p at 0 is 1, that gives us 10. So we know that a sum of 10 was gained from 0 to 2, but remember when we're calculating the sum of a sublist, the left bound and right bound are both inclusive. So if we actually calculate the sum of the sublist right here from 0 to 2, we get 11. 1 plus 3 plus 7 is 11. But we're only getting 10 because we're only seeing how much sum was gained from 0 to 2. We're not including the value that's actually at index 0. So if we want to include the value that was at index 0, we would do prefix sum at index 0. We would do prefix sum at index 2 minus prefix sum at index 0 plus the value of the list at index 0, because we don't want to exclude that first value. So we want to do the value of the list at index 0, and then plus how much sum was gained from 0 to 2 would give us the sum of that sublist from 0 to 2. And if you do the math, you'll get p at 2 minus p at 0 that would be 10, plus L at 0, which is 1, and that gives you 11, which is the sum of the sublist. 1 plus 3 is 4, 4 plus 7 is 11. So if you understood that, now we can get into the code. So we need to define a function called, we can say compute, or we could just say, compute sublist sum, and we need to pass in a list. We need to pass in a list, and then we also need to pass in two index parameters, the left bound and the right bound. So we'll call that left, we'll call that right as the parameters. And then we need to compute the prefix sum, so I already showed you that algorithm. So we need to create a prefix list, and we can initialize it. We can initialize the first element to the first element of the original list, and then we need to loop through from 1, because we need to skip that previous element, or that first element, because we already know what that is. We want to loop from 1 to the length of the list, and then we're going to update the prefix value at that index to the prefix sum at the index before, so the cumulative values right before that index plus the value at that index, which gives us the new cumulative sum at that index. So plus at, so prefix at index I minus 1 plus li at I, or the list at I. So that gives us the prefix sum. And then if I want to compute the sublist sum, now all I have to do is print prefix at right, so the right bound of the prefix minus the left bound of the prefix, which gives us how much sum was gained, plus the value of the list at left. So not exclude that. We can't exclude that. This expression only gives us how much sum was gained, and then we have to add that to the initial starting point value, because we have to make sure that the left is included. And then so now we can declare a new list, so let's call that L. And then in this example we used 137 negative 29. And then we can call compute sublist sum, pass in that list, and then we use 0 and 2 in the example, so that's what I'll use. Left bound is 0, right bound is 2. And then we can see if that works. So, okay, so computer, it was just a typo right there. And then yeah, you see, if we run it, we get 11, and 11 was our answer here as well. So if we calculate the sum of the sublist from 0 to 2, we get 1 plus 3 plus 4, which is 11. So anyway, we got the right answer. So I hope you learned something from that video, and that's basically the purpose of prefix sum.